Hey everyone, today I want to complete 427 assignment. I will be completing this quiz to help you out. So this quiz will be more on trigonometry. Let's see what we have. Below is the graph of this function. It intersects its midline, and at that point it has a maximum point at that point. What is the amplitude? Okay, now we did watch these videos that went over these definitions, but if you're still confused, let's say you don't know what midline is. Well, you can look it up, right? What is midline of... Now, these are not really great, but you wanna look at math, right? The midline of a sinusoidal function is the horizontal center line by which it oscillates above and below. Sinusoidal means have a sine curve, so just like those curves. Oscillates means move back and forth, so just a sine curve and moves back and forth between the same numbers. Now here, the midline is 0 because this is just kind of the middle section of it. So just asking where's the middle section of it? Here it's a y equals 2, here it's a y equals 0. We also have amplitude. What's the amplitude? Amplitude is 1/2 the positive difference between the maximum and the minimum. So all it's asking is from the midline to a high point or a low point, what's the distance? So kind of how far does it go up or down? So it could go up a lot, it could go down a lot. You want to know here that the amplitude will be the same whether it's the high minus the mid or the low minus the mid, right? Because the middle line is the middle distance between the high and the low. The middle line, the midline, is exactly halfway between the high point and the low point. So if I return to my graph, the midline is right here, and the maximum point is right here. So if I want to find the amplitude, I want to find the distance from here all the way down here. So it'll be kind of a straight line shooting down until I reach the midpoint. You might be asking, well, do I want to find like what this, how long that curve is? Amplitude is just up and down. It's just a vertical distance. It's just up and down. It's just a height. It's a height, right? Okay. If you want to find what that curve, that kind of is calculus, but we don't care about that right now. All I care about is the vertical height of this line. So how do I find the vertical height? Well, I have 6.75. I have 2.75. To find the distance between them, I can just subtract them. So I would do 6.75 minus 2.75. What is that? I think that's 4, right? 6.75 minus 2.75, that's 4. That's the distance between this high point and the middle. It's 4 units. What is the period of this function? Given exact value. Okay, what's period? Periodic function. Here, look at this. The period of function is a horizontal, so it's a horizontal length of one cycle. Amplitude is vertical, up and down. Period is left and right. It's horizontal. Okay. Because there's a lot more here. But we're just using period. So the period of, it's basically asking how long does it take to go from a point to the same point. So if I graph sine, if this is just sine of x, if it just is the basic graph sine of x, if it's just the basic graph we know, the period will be the distance from this point until we reach it again. Over here, it's one complete cycle, up, down, back. That's one cycle. this is the period. So, to find the period, I need to know how long this distance is. If I look at a graph of sine of x, so if I want a graph of sine of x, just the basic graph, if I want to know the period of it, well, that's the distance from, let me see if I make this larger. So the distance would be from it's one cycle, right? So up, down, back. This is one full cycle. What's the period? Well, this is 0. This is 2 pi. What's the distance between 0 and 2 pi? The distance between 0 and 2 pi is 2 pi. So the period is 2 pi. The period is 2 pi units. Okay, now that's for basic sine of x. So what happens here? Do I care about this? Does this affect the period? Probably not. Right, this just kind of, well, sorry, this is kind of a hard question. Let me look at Desmos to help you out. So Desmos, I think this is the amplitude period. So feel free to use these to help you out. So here I see A will be 3, right? A is 3, and B will be 2. So B will be 2 here. I don't really care about these. These will just shift it. I do care about amplitude. This will be the amplitude. This will be the period. Well, sorry, these will help us find the amplitude and the period. So I have this graph right here. Now if I zoom in, we can see the period is this, it's hard to see, but it's this purple line from here all the way into here. What do you think this is? So this is one cycle. It ends here. What's the distance between this and this? Let me zoom in some more on it. It looks like it's about 3.14. Well, what's 3.14? It's pi, right? You see, so the answer is pi, and here's why it's pi. If I make this just 1, you see how the period that's expanded, it goes from 0 to about 6.28. That's pi times 2, right? 3.14 times 2 is about 6.28. So this is the normal period that we expected. That's this period right here. So when I double it, sorry, when this goes from 1 to 2, what happens? It shrinks up by half. Or sorry, it shrinks up by a factor of 2. So now it shrinks up to a factor of 2. You see from 0 to 2 pi, there's actually 2 cycles here. 1 and 2. So one cycle is 0 to pi. The second cycle is pi to 2 pi. But the basic period here is 0 to pi. The period is just pi units. Because it's double. You see this 2x? It's double. It has double the frequency. It'll be twice as fast, so the period will be cut in half. So what's the midline equation? I think it's pretty obvious if you just look at this, right? It'll be about right here. Because this is about halfway between this and between that. Okay, but let's do the math way. The amplitude is 1.5. So this distance from here to here is 1.5. So what's 1.5 plus another 1.5? That's 3, right? This is 3 right here. So the midline equation is y equals, because this is 1.5 up, another 1.5 up makes it 3. It's the midline equation of this. Now this is hard, right? I don't doubt that this is difficult. This is where you can kind of return to watch the videos if you want. I think I can do this in my head. Let me check. Now, let's see what numbers I should focus on. What the midline equation? So, do I care about this number? What's this number? The amplitude, right? Do I care about amplitude? Well, no, not really, because look, if I change the amplitude, does the midline change? No, the center is still right here. So even if I change it, the center is still the middle. That doesn't matter. What about the period? Does it matter if I change the period? No, because it's still in the middle, right? The midline is still the center part right here, even if I change the period or the amplitude. So I actually don't really care about these numbers. You don't really need to care about them. What I do care about is these numbers right here. This will be -1 and -4. Okay? Now, do I care about -1 here? -1, do I care about that? This is kind of a hard question. Which one do I care about? So my answer here is that you should care about this -4 right here. And if you didn't know how to come up with this, let me explain. So let's say I have just a basic sine of x. If this is just a basic graph, what happens if I subtract 4 from it? So I have sine x minus 4. If this is my new equation, what happens to this? Well, whatever this value will be, I subtract 4 from it. So every value you see here, every point you see here, will move down by 4. Because whatever this is, I subtract 4 from it. So everything will move down by 4 units. It all moves down by 4 units, and so my new equation will look something like that. Right? But everything moves down. Everything moves down 4 units. Does it change the midline? It does. Right, so the midline went from this line right here down to this line right here. If the midline went, you see how every value went down by 4 units. Every value went down by 4 units, so what happened in the midline? How many units is it down? 4 units, right? It went down 4 units because every single value here went down by 4 units as well, so the center line moved down by 4 units. That's -4. Now, if that doesn't make a lot of sense, here's a way you can kind of cheat by using Desmos, right? If I just want an expression, y equals 10 cosine of 6x minus 1 minus 4. Okay, that's it. That looks kind of ugly. But that's because the amplitude is so high and the period is so high as well. But you see the center line, it's kind of hard to tell. If it's at 0, let's see. I'm looking for the midline. Well, what's this high point right here? It's 6, right? This is 6 up here. That's 6 up there. What's this point down here? It's -14. Okay. Now, what's the distance from 6 to -14? The distance from 6 to -14 is 20 units. So the distance from 6 to -14 is 20 units. This is 20 units long. Okay? That means the midline will be 10 units from each one. It'll be the average. So, what's 6 minus 10? 6 minus 10 is -4. What's -14 plus 10? -14 plus 10 is -4. So that's kind of another way you could do this if you want. This is 6. This is negative 14. The average of these two numbers will be right here in the middle, negative 4. So the answer is negative 4. What's the period of this function? So I see the midline is right here, and the amplitude, sorry, the low point is right here. This is kind of tricky to think about. So what you should be thinking about is, what's a full cycle? Where do I see a full cycle here? I see a full cycle from about this point right here until about this point, I think right here. So this looks like a full cycle to me. Up, down, and back. That looks like a full cycle. So I want to find out, how large is this cycle? Okay, maybe you can kind of look at this negative 6 to 8, but let's do it in a math way. Okay, now you see this, I can find out what this distance is, right? I can find out the distance from here to here, because that's 4.75 minus 1.25, that's about 3.5. So this distance is 3.5. To go from the midline to a low point, I add 3.5. From the midline to the low point, I add 3.5. 1.25 plus 4.75, sorry, 1.25 plus 3.5 is 4.75. So, well, look at this. So to go from a midline, to go from the center to a low point, I add 3.5. Well, this is symmetrical, right? This is perfect. So it must be the same distance over here. To go from this center down to the low point, it still must be 3.5. So to go from this center to low point, 3.5, center to low point, 3.5. Okay? Now, this is still center. So I see that half this cycle is 7. Half the cycle is 7 because it's 3.5 plus 3.5, center up, sorry, 1/2 is 7. Because it's 3.5 plus 3.5, that takes me from a center to another center. I put the whole thing. What do you think the whole thing is? It's also 7, right? If half a cycle is 7, if only this half is 7, then the whole thing must be 14. And you see here that it ends at about 8. It starts at about negative 6. So what's the distance from 8 to negative 6 is also 14. So that's another way you could have done it, just by looking at how long a cycle is. Sorry, so it's 14 units right here. Okay, one last question. What's the amplitude of this? What I'm looking at here. So if I go back to this, go back to this. What changes the amplitude? I want to find the amplitude, right? So the amplitude is the up-down part, right? It's the up-down part. What changes the amplitude? Well, it looks like this changes the amplitude, right? The A, the first number you see. What's the first number you see? It's a negative sign. What's a negative sign? This is negative 1. So it's negative 1 times sine of 8x minus 3, blah, blah, blah. So what happens if A is negative 1? If A is negative 1, the amplitude looks like it is just 0 to negative 1. The distance from 0 to negative 1 is just 1. So it just is 1 unit. You also see how they answer the question. Oh, they have this middle equation. Does this look familiar? You remember HK, y equals a times x squared, hk, all that fun stuff? Yeah, kind of the same thing here. You just look at the numbers, okay? And you can, here's a video if you still need help. But yeah, it's just one. Hope you learned something, and I will see you later.